Hello everyone, this is Neil from Edureka and welcome to this blockchain tutorial session. Now blockchain and Bitcoin are some of the most trending keywords as part of today's technology, and even those who are not familiar with cryptocurrency are quite interested in the same. And today's session will give you a complete idea with respect to both. Without wasting any time, let's move forward and look at today's agenda for the session. Now blockchain is being used highly for transaction management, and it is replacing the current existing transaction management system. If a technology is replacing the existing systems, there must be certain problems, and that's exactly what we'll be discussing at the first. Once we've understood this, let's try to discuss how Bitcoins can help solve these issues as well as how the Bitcoin transaction takes place. Now if a transaction has to take place, there needs to be certain medium, and that's exactly what blockchain is. Moving on from there, we'll try to talk about the various blockchain concepts, the various blockchain features, as well as we'll see where blockchain is being used apart from the banking domain. Finally, towards the later half of this session, we'll be looking at a banking use case demo where what we'll be doing is we'll try to create an alternative banking system as well as we'll try to make it a bit better. Since you are reinventing something, let's try to make it better than anything that is there. So for that, first what we'll be doing is we'll be installing 𝐂𝐸𝐴𝐶 and then we'll be registering an account to 𝐂𝐸𝐴𝐶 blockchain. 𝐂𝐸𝐴𝐶 basically is an online blockchain system which helps you manage your cryptocurrency. Once you've done this, we'll try to create a private autonomous blockchain on our system itself, and then we'll try to perform transactions internally. Now these are mock transactions, but it'll at least give you a complete idea of how a blockchain system works as a whole. So can you guys give me a quick confirmation in the chat box if you're clear with today's agenda? Okay, so I seem to have got a confirmation from Deepika, Matilde, Aditya. It says it looks great. Ravi says promising. That's great to see that you guys are interested for this session. So without wasting any time, let's move forward to the first topic of this session, that is the issues with the current banking system. Now before I go ahead with the slides, can you all take a moment and please tell me what do you feel is the issue with the current existing banking system? So this can be something that you feel as such is wrong with the current existing system. So please put it across in the chat box. Okay, so I've already started getting a few of them. Let me pick them out. So there are variating interest rates, definitely agree on that. Transactional charge with everything, definitely that is another problem. Financial crisis, yes, definitely agree to that as well. Net banking frauds, definitely that is another problem. So there are multiple problems that you can see as part of the current existing system, and this in turn led for the requirement for a parallel system. But before we go into the parallel system in detail, let's try to talk about the challenges that are faced with the current existing banking system. Now, the first challenge we'll be talking about is the transactional fees. Now, let's take the simple example here. When Chandler wants to send $100 to Joey, due to a transactional fees of $2, Joey ends up getting only $98. Now, it may not seem a huge amount, but let's assume that every day there are 10,000 transactions that happen. And in that 10,000 transaction, even if it's a 2% commission, it's a huge amount that we're talking about. Now, if you look at what is given here, in the year 2015, three organizations, that is JP Morgan, Bank of America, and Wells Fargo, made close to $6 billion just from ATM and overdraft transaction fees. So this is a very huge amount. And most banking and financial organizations depend on these kinds of fees to have their source of income as well. Now, wouldn't we all like not to have a transaction fees? Because every transaction that we make, be it in an ATM, be it a net transfer, be it bank withdrawal, everything these days comes with a fixed transaction fees. Even though it would be a small amount, wouldn't we be happy if we could save that? Definitely, I do want to save that. So moving forward, let's talk about the next problem that is there with the existing banking system. Now this is a challenge that you would have seen if you're from a financial domain, but to those of you who have not heard of double spending before, let me put it very simply. Take the example here. Peter has $500 in his account, but what he's trying to do is that at the same time he's trying to send James $400 and Mary $500. Now if both transactions go through at the same time, then it becomes problem to identify which is valid. Because the digital signature attached with digital transactions can be to an extent falsified and copied as well. This makes double spending quite possible and is something that is of a challenge. Now this is one challenge that most banking or digital financial solutions had faced across when they were working with online payment transactions. Apart from this, there's also the challenge of financial crisis and financial depression. Now, all of us remember the depression that had happened in the year 2008. Now, to put it very bluntly, one of the key factors which led to this depression was because financial organizations and banks had actually lent out all their money as subprime mortgages to people who couldn't afford to pay them back. This in turn led to a huge fall with respect to real estate value and created a huge financial crisis for everyone who was associated with respect to that. A lot of people lost their jobs as well as money, but then again, this was something that people had done to try to get rich. So now comes the question that how can Bitcoin solve these issues? Now to understand this, let's take these four issues in itself. The first is the issue of centralized power. Now when I talk about a centralized power, every monetary system that's out there today is controlled by a central governing authority. It could be a federal body, it could be a unanimous personality, and so forth. Almost all currencies out there today are actually controlled to an extent by a central authority. However, with Bitcoin, this system got decentralized and distributed among everyone who was part of the Bitcoin system. And it keeps growing on. Let's say tomorrow you move into the Bitcoin system, then definitely you are also part of it and you hold a certain power to that as well. Now how that happens, that we'll be talking in our upcoming sessions as to how the value of Bitcoins keeps changing. But for now, let me just help you understand that anyone who becomes part of the Bitcoin and blockchain system becomes a powerful person, and the power that is held by one single authority gets distributed to everyone who's part of the network. Apart from this, most banking and financial organizations follow a private ledger. The only thing that you are aware of when you put your money into something is whether or not there's certain transaction that you have made as a person as such. You have no idea whether someone else has taken some money, whether the bank has in itself invested this money somewhere, and so forth. However, with blockchain system, the ledger in itself is public. Everyone who becomes part of this blockchain network gets a complete copy of the entire blockchain as soon as they sign up. So immediately when you sign up for the Bitcoin blockchain, you get a list of complete transactions that has happened from the start of Bitcoin transaction. Now that's a huge amount of transactions, but blockchain makes it very easy as well as completely secure to store all this transaction detail, and at the same time ensures that none of this gets manipulated. As to how this can be completely secure, we'll be talking in the upcoming slides, but I hope you get a simple understanding. Now, although it is a public ledger, you can have the complete details with respect to the transaction that happens as part of the network. You still don't know who exactly is doing this transaction. And this is the anonymity that blockchain gives you. Really neat, right? Definitely. Now, the other challenge that most transaction and financial organization faces is the challenge of hacking. Every now and then we do hear that a financial organization has been hacked and certain data has been leaked, certain transaction details are released, certain amount has been stolen from their accounts, and so all this is something that we have heard every now and then. But blockchain system is completely immutable to hack. Any transaction that takes place cannot be modified ahead. And even if you try to modify it, the blockchain system is built so securely and so smartly that this false transaction detail gets rejected. Now don't worry about how this happens, we'll be talking about that in the upcoming slides. Moving forward, coming to the final challenge, that is the double spending problem. As I had mentioned, most financial organizations that have a digital platform have faced the challenge of double spending. Through blockchain system, double spending is not possible. And this is basically because of how the blockchain system in itself was structured and created. Now, the double spending problem was something that was faced quite popularly at the time when the blockchain system was becoming popular. Keeping this in mind, they had structured the blockchain system in such a way that even in future, the challenge of double spending can be completely tackled without any problem. Until date, you do not have any transaction that was part of the double spending issue. So are you guys clear with respect to these points? Any doubts with respect to this? Okay, Mitchell is asking me, if I have the access to the complete ledger, can I not modify it as per my requirement? Definitely not, Mitchell Day, definitely not. Because we will be talking about the challenge just to do that in the upcoming slides. But to give you a clear-cut and straight idea, let me clarify it now itself. This is one of the key reasons why blockchain is highly being used in today's payment platform. You cannot directly modify even a single transaction that's part of the blockchain. Now, literally, let's say you are trying to modify a specific block which has the complete transaction details. It's going to cost you at least half the world's resources. And why is that? We'll be talking. For now, let's say it's going to be very expensive and impossible task for one single person or a group of people to modify a transaction part of the blockchain. Are you clear, middle day? Great. Now the first challenge that we had spoken about was the transaction fees. Now today there are close to 650 different kinds of cryptocurrency, but most of them don't even charge a minimal transaction fees. You can transfer your money from one account to the other account at no transaction charge. But let's say if you do wish to add a specific transaction charge, you can do that. There are certain cryptocurrencies that do follow a specific transaction fees, but this is comparably minute when you see the transaction fees that is associated to a bank transaction. So does this solve most of your problems? Can I have a quick confirmation in the chat box? Okay, so Aditya is asking me how realistic is it? So Aditya, let me give you this understanding. The value of a Bitcoin was somewhere close to $1,100 in the start of the year, that was January 2011. Today it stands somewhere close to $2,800. This basically has grown because of people's belief in the system and their investment into the system as well. So the more people trust the system and invest their money into it, the more the value keeps growing. And every day you have new people who are moving into the Bitcoin system rather than sticking to the conventional banking system. Now there are a lot of security features that come with respect to this, which we'll be talking as part of today's session. Let me put it this way, Aditya. Most people who are part of the financial domain today are already moving into cryptocurrency market or have already moved in. So definitely this is something that will rapidly grow as well. Chandrasekhar is asking me how can I purchase a cryptocurrency or Bitcoin. Chandrasekhar, that's quite easy. All you have to do is register for a cryptocurrency wallet and then you can go on to purchase. There are different sites that help you do that with different charges. You can just have a look at that. It's quite easy. You can just check it out. Okay, there's a question here from Deepika. Deepika is asking me if there is a choice of no transaction fees, why would there be people who add a transaction fees with respect to that? Okay, Deepika, let me park your question aside for now. We'll come back to this. For those of you who are not clear on what Deepika asked, she quite simply asked, if I don't have to pay, then why do some people pay for the transaction fees and some don't? So we'll come back to that. Don't worry. If you're not clear at that time, we'll take this question up back again. Is that okay, Deepika? Great. So since all of you have understood till here, let's talk about the Bitcoin transaction system. But before we actually talk about the Bitcoin transaction system, what we need to understand is what exactly is blockchain. Blockchain basically is the core technology behind Bitcoin in itself. You can say it is the spine of Bitcoin system. To put it quite simply, blockchain is actually a public distributed database which holds the encrypted ledger. So why is it encrypted? To keep the details of the people involved in it completely anonymous. Apart from this, what exactly is a block, you might be wondering. A block is a collection of all the recent transactions that have happened and are verified. You group all these transaction details, create a hash code for this, and then you store it in a block. Once the transaction is verified, then what happens is this block becomes a permanent part of the blockchain and the chain keeps growing. So it is believed that every 10 minutes a new block gets created and the blockchain keeps growing accordingly. So how many transactions happen with respect to that time frame, all can be grouped as part of the block and then stored into the blockchain's block. But then again you might be wondering, what exactly is Bitcoin in itself? So don't worry, that's exactly what we're talking about next. Now Bitcoin is the first decentralized digital currency that came into the market and was introduced in 2009 by a pseudonym called Satoshi Nakamoto. Now he brought in the concept of Bitcoin and blockchain together in an open paper, and this was something of a revolution. It was not until July 2009 the first blockchain came into implementation and became quite popular since then. Now you may be wondering, since it's a decentralized and a digital currency, can't we just keep creating Bitcoins as per our needs? The answer is no. Bitcoins use various cryptographic as well as mathematical problems that ensure that the creation as well as management of Bitcoins is restricted. Now, there are only 21 million Bitcoins that can be created, and as on 2016, we've almost created 14 million of them. So what Bitcoin community has done is that they keep upgrading the algorithms as well as cryptographic technologies involved in Bitcoin on a regular basis. This ensures that even if there are more miners that come into the Bitcoin technology every day, that the Bitcoin system does not get exhausted. With the increase of complexity, it ensures that only by 2140 does the last Bitcoin get mined. Apart from this, the ledger system, which keeps a track of how much Bitcoin gets transacted, is in itself completely electronic and highly secure. Now, if you need to change any specific transactions, let's say you are trying to send someone Bitcoins that you don't have. Let's say I want to send 500 Bitcoins to every one of you who are part of this session. This becomes impossible because the ledger in itself is completely electronic, as well as every transaction is verified and validated before it gets added to the block. Now, going back to our previous topic, that was blockchain. Now, in a block there are mainly three key concepts. The first is the previous block's hash code. Now, every block has a specific hash code associated with it, which is used as an identifying factor for that block. Now, this hash is something that gets created with a very complex hashing algorithm, where even a minute change with respect to the input can create a highly different hash output as whole. Now, you cannot reverse engineer this hash code as well. The algorithm is created in such a way that no one can actually get the complete data by reverse engineering the hash code as well. Apart from this, you have the complete hash details of every transaction that has happened as part of that block. Now, there could be multiple transactions that happen at one go. So every verified and validated transaction gets added to block, with thereby ensuring that this transaction cannot be manipulated. Apart from this, the third thing that needs to be part of a block is basically the value or proof of work for that block. This basically is a mathematical solution that you attach with the block to ensure that this is a valid block. Now, we're not going to go in detail with respect to the mathematical proof, but we'll talk about that in the upcoming slides. Now, you may be wondering, since it is a ledger and everyone has access to it, can I just not directly modify the ledger or the transaction? Definitely not. These ledgers are something that gets created by softwares, which in itself have to solve a mathematical problem to get the valid output. So as I had mentioned, all the output gets hashed, and this hash value is what becomes a proof of work. So even if you try to falsify, or even if you try to fake a specific transaction or a detail with respect to the ledger, it is not going to get accepted. Apart from that, since the ledger in itself gets distributed throughout the network, everyone has a valid copy of the same. Let's say if you try to change even one specific transaction which is part of the block, it does not get accepted because majority of the people of the network have a copy of the block which is valid. So your modified block or transaction gets completely rejected and does not become part of the original blockchain as a whole, thereby ensuring that every transaction as well as every block is highly secure as well as valid and verified. So are you guys clear with respect to what is a blockchain and what is a Bitcoin? Okay, so Andy is asking me, can I purchase Bitcoins? Definitely, Andy. Anyone can purchase as well as perform transactions using Bitcoins. You can do that using various online platforms which help you convert your currency into Bitcoins. Now, you can choose whichever is as per your requirement, but to put your answer quite simply, yes, anyone can use Bitcoin and blockchain. Okay, I have a question here from Puneet. Puneet is asking me, can Bitcoin or blockchain system be hacked directly? I have heard this. Okay, Puneet, let me put it across. Till date, there has not been even one single incident where Bitcoin or the blockchain system has directly been hacked. Okay, although blockchain system in itself is being implemented with other applications, there have been certain incidents where the application gets hacked, but the blockchain system till date has never been hacked. It's the application which is built on top of the blockchain that gets hacked, but trust me, the blockchain in itself can never be hacked or modified. Does that answer your question, Puneet? Okay, that's great. So moving forward, let's try to understand how a Bitcoin transaction takes place. Now let's take a group of 8 people who are part of my blockchain network. Okay, you have James, you have Steven, you have Rahul, Kevin, Paul, Robert and Lisa. Now James wants to transfer 500 Bitcoins from his account to Kevin's account. Now just because James wants to transfer 500 Bitcoins to Kevin's, it may not seem possible. To give you a better example, let's say I want to give every one of you who are part of this session 5 crore rupees. Sadly, I don't have enough balance, so I can't do that. But that same thing needs to be validated by someone else. And that's exactly what the role is of Robert and Lisa, who are special professionals called miners. Their main job is to see whether James actually has enough sufficient balance. Now, there are a lot of protocols as well as security features that come into this, and we'll be talking about each one of them one by one. James here wants to transfer 500 Bitcoins to Kevin, and Lisa and Robert's job is to verify that they have sufficient balance. Now before we go on, let's look at a sample ledger here. Here you have account number as well as the balance that is there after each transaction takes place. Now this balance gets updated every time a transaction gets introduced, and the ledger in itself gets updated with respect to every transaction. So here, rather than having the details with respect to one single account, you store the details with respect to the transaction as part of the block. This again ensures that even though there are details with respect to the transaction available, you cannot directly attack or hack the end user and take away his money from his wallet. Although there are different kinds of cryptocurrency system in the market today, to give you a simple example, blockchain system actually keeps count of the unspent transaction output, whereas your systems like Ethereum follows an account-based system where an account balance is also stored. So based on different kinds of requirements by the user, you have different kinds of blockchain in itself. But we're going to be talking mainly about Bitcoin blockchain itself. So we'll be talking about the unspent transaction output. That is the amount of Bitcoins that are unspent. Now before we move forward, let's assume that the third entry present here is of James, who has to send 500 Bitcoins to Kevin. So I'll take this entry to be Kevin's. Okay, I hope all of you can see this. Great. Now here what needs to be done is that 500 Bitcoins has to be taken from this account and has to get transferred to this account. Now if the transaction is successful, since James has sufficient balance, the transaction will definitely go forward and the account balance of Kevin gets updated with respect to everyone who holds the copy of the ledger. That is, this transaction is successful, gets broadcasted to everyone across the network who's part of the blockchain, and they themselves update their ledger accordingly. But then you might be wondering, whose job is it to verify that this transaction goes through and James has sufficient balance? That exactly is what the job role of miners Lisa and Robert is, as we have discussed earlier. Now what is going to happen is that Lisa and Robert are in turn going to check the complete transaction history of James. They're going to see if at any point James has received more than 500 Bitcoins or at least holds a corresponding previous balance of above 500 Bitcoins. So let's say there has been a scenario where Rahul had sent him 600 Bitcoins. So this in turn makes it quite easy, and you can immediately see that okay, he has received 600 Bitcoins. So I don't need to look any more further. I can definitely ensure that this transaction can go through, since James has not spent it also. But let's say James has received from Steven, let's say 200 Bitcoins, Rahul has sent him 100. So I need to keep checking all the previous transactions to verify that he has sufficient balance, including his credit as well as debit history, and then decide whether this transaction can go through. Now this is exactly what Lisa and Robert as miners do. Now once they have validated that James has sufficient balance in his account to transfer 500 Bitcoins to Kevin, then what happens is that this transaction gets added as part of the block. And once the block in itself gets validated, the money gets reduced from James's account and goes to Kevin's Bitcoin account. Now usually this whole process of a block validation gets completed in 10 minutes, but it is suggested that you wait about 30 minutes to confirm a transaction. Now why is that so? We will be talking in our next session, but for now just keep this in mind. Now again, since every transaction gets validated by a miner, they go back to all their previous history and keep checking. Now let's say James at the same time had tried to send 500 to Kevin and 500 to Rahul, having only 500 as part of his balance. Then what would happen is, since each transaction is individually being checked, the transactions would go through one by one. Now since James has sent Kevin 500 Bitcoins, the transaction which is sent from James to Rahul won't go through because he recently just spent 500 Bitcoins and he only had 500 Bitcoins as part of his Bitcoin wallet. So therein it completely avoids the problem of double spending that we had discussed earlier. So are you guys clear with respect to how a Bitcoin transaction system takes place? Now don't worry too much, we are not going in detail with respect to how completely it works. There's a separate session on that, but I at least hope you've got a complete overview of how things work around. Okay, I have a very good question here from Deepesh. Deepesh is asking me, if James requests two transactions and Lisa is taking care of one transaction while James is taking care of the other transaction, isn't there chance of double spending? Okay, now Deepesh, that is a very good question, and we will be talking about that in the next session actually, where I'll completely show you how it is impossible for anyone to actually do double spending challenge. Now, since both of them are trying to confirm this transaction, it can take both of them different times to confirm this transaction. There's a very good chance that by the time Lisa has verified the first transaction, she's going to broadcast this to everyone in part of the network, and Robert, although he's still verifying, gets the update and then realizes, okay, this is a double spending problem, he can avoid this transaction. But there's very minute chance that both of them solve it at the same time and both of them confirm it. But even then, there is actually a solution to that. Now, to put it in simple ways, what happens is the message gets transmitted across multiple peoples in the network, as we have told. Now, the message gets transmitted accordingly from Lisa as well as Robert at the same time verifying the transaction, which in turn causes the issue of double spending. But the person who solves the next block, his input, that is whether he's got the transaction confirmation from Lisa or from Robert, whichever transaction he has accepted, that will be accepted and the other transaction gets rejected. I hope you've got a simple understanding of this, 𝐸𝐵𝐴. Now don't worry, we'll talk about this extensively, how the blockchain algorithms ensures that the double spending problem doesn't happen. Okay? Yeah, good to see that you've understood 𝐸𝐵𝐴. Any other questions? Okay. It's good to see that you guys have followed me till here. But let me ask you this. Why would Lisa and Robert actually sit down and validate their transactions? What do they have to gain? What do you think? And it's not easy to validate a transaction as well as mine a new block because it requires a lot of resource. In today's world, it's highly impossible for a single person or an entity to mine a complete block. So it requires a lot of resource as well as investment. So why do you think James and Lisa do that? Okay, Deepika tells me they may get some transaction charges. Deepika, again, we spoke about this earlier as well. The transaction charges are completely neglected here. Even if you go by the minimalistic amount, that is 1 millionth Bitcoin. So that's not a huge number for them to invest. They would be investing a lot more than that. Okay, don't plunder your heads anymore. Let me answer that. The miners who validate the transaction as well as complete the next block of the blockchain get a 12.5 Bitcoin as an incentive for the creation of the new block. Now this is something that gets created out of thin air and gets added to their Bitcoin wallet associated to it. Now 12.5 Bitcoins is not a small amount. In today's value, it's somewhere about $33,000 to $34,000, which is a very huge amount. And you also need to understand that almost every 10 minutes a new block gets created and becomes a part of blockchain. So you can assume that every 10 minutes $33,000 gets credited into someone's account. But it's not as simple as you think. Mining requires a lot of investment, and as I had mentioned, it's not easy for one single person to mine the resource. So in today's world, what happens is a lot of miners come together and form something known as a pool. These people invest all the resource that they have to solve the pool together, and based on how much resource that they have invested in mining the pool, reward gets distributed accordingly. Now let's take a real-time scenario, $33,000, and let's say there are 11 people as part of that. Each one gets close to $3,000 in itself. $3,000 again is a huge amount for something that requires 10 minutes to mine. But again, let's not go into how much efficient it is to mine the resource and all that. We will talk about that in the upcoming sessions as well. But just to give you a simple idea, there's an incentive also added to Lisa and Robert. Middle Day is asking me, can anyone become a miner? Definitely Middle Day, you can definitely become a miner. All you have to do is register as a miner and then allocate your resource accordingly. Now again, there are a lot of sites that help you do this, but again, what I would request you is to check whether you're actually going to get any profit before you become a miner, because again the resource needed for mining a block is not less, and day by day it keeps increasing as well, because the complexity involved in solving a block keeps growing day by day. As we had mentioned earlier, there is a certain level of complexity that is involved in mining, and this keeps growing as time goes, because a lot more people are mining today when compared to 6 or 8 months back, and this is mainly because of their attraction for the incentives. But at the same time, since more miners are coming, we need to ensure that the Bitcoin system does not get depleted. As I had mentioned earlier, there's only 21 million Bitcoins that can be mined. So the system in itself makes it difficult for you to compute the resource. And as I had mentioned, just check how efficient it would be for you to become a miner. Okay. Great to see that you guys have understood till here. Now it's time we try to understand how blockchain achieves the Bitcoin solution or the Bitcoin parallel system. Now, what happens first is that there's a request for transaction initiated. Basically what happens is someone requests a transaction, Now it's quite easy for anyone to request for a transaction. All you need to do is that you need to have the details to whom you're sending. And with respect to details, you need to just have a unique number that they're going to be sharing. Now what exactly is this unique number? We'll be talking in the upcoming slides. But there are certain cryptocurrency wallets that even let you scan the QR code of the sender and initiate this transaction as well. So it's quite easy. All you need to do is enter one specific unique number that they provide you with. You have to enter your unique number, and then you need to specify the amount that you need to send to them. Once you do this, it gets transmitted across to everyone who's part of the Bitcoin network. Once they receive that and validation of this transaction is done, then the verification goes on, and then this transaction becomes part of the new block which is going to be added to the existing blockchain. Once the new block is created, it goes on to get added to the existing blockchain and the transaction process gets completed. Quite simple, don't you think? Definitely. Herein it also avoids the need for a third party who in turn acts as a mediator between the sender and the receiver. Thereby this exactly avoids the need for a transaction fees as well, and is one of the key factors that has increased the popularity of blockchain and Bitcoin network as such. Great. So moving forward, if you talk about blockchain itself, blockchain basically is the spine of Bitcoin system. It is again a publicly distributed database where you're holding encrypted ledgers of everyone involved in the blockchain. Now once a transaction gets verified and validated, it becomes part of the new block, and the new block in turn gets added to the blockchain. Now the number of transactions at this point could be all the recent transactions or only those that have been completed as well. This depends on the total number of transactions that get verified and validated in the time that a new block gets created. So each block, once it's completed, gets added to the blockchain and the next block's work begins. Again, the next set of transactions get added on to this block, and in turn it gets added to the blockchain, and it ever keeps growing up. Now as I had mentioned, once you join the blockchain, you can get the complete block list right from 2009 when the first blockchain was implemented. Moving forward, let's try to address the three key features that make blockchain so popular. The first is the blockchain cryptography. Now you use a combination of public key and private key cryptography, apart from also using a highly secure hashing algorithm. Now this hashing algorithm is so precise as well as complex that even a single space or a comma can make a huge difference with respect to that same. Apart from this, we use a P2P network, that is a peer-to-peer network, which ensures that there is a complete consistency with the blockchain. Let's say even if one person tries to make a slight change with respect to a transaction or a block which is part of the blockchain, then that changed block does not get added or reflected in the blockchain. Because most people in the network have the original blockchain, this changed block does not get accepted and gets rejected as well. Apart from that, the program in which blockchain is created has a lot of protocols as well as security feature in itself. Now talking about the private key cryptography, here again you use a public key and a private key. What you do basically is that you share your public key. This is similar to the account number that we had discussed earlier. So what usually happens is that in case if you do want to send your money to someone, you basically request them for their public key, and then what you do is you share your public key, their public key, as well as the amount that needs to be sent as part of the transaction details. Now based on what data you're sharing, you can select whether it has to be encrypted by the public key or the private key, and the other would be used for decrypting the data. It's completely an asymmetrical encryption process that takes place. Now apart from this, we use a P2P network. How does the P2P network work? Now suppose A, let's call A as Andy here, finds out that a transaction has come in which Bobby wants to transfer 5 bitcoins to Cindy. What happens is that A broadcasts this message to both B and C, who in turn verified it and transmitted accordingly to their peers as well. Now once they have transmitted to their peers, they keep transmitting it across the network, and this transaction gets propagated throughout the network. Once this transaction gets propagated and a new block is about to be created, the transaction gets verified and validated and then gets added to the new block in itself, thereby keeping a complete consistency. Now you may be wondering what happens when one person as part of the network tries to make a modification with respect to this transaction details. As I had mentioned earlier, it is not possible. Let's say this node is called D. Now what he does is that he actually modifies the data, suggesting that the amount has to come to D rather than it has to go to C. and he propagates it to his nodes. Now, what happens is that once this gets propagated throughout, there's a majority and a minority difference here. Now, there's a certain limit that D can propagate his data to. But since the majority of the people have the correct details that it is B who wants to send the 5 bitcoins to C, not D, the transaction detail with respect to which is original gets accepted and the modified transaction detail gets rejected. Now, I hope this gives you an understanding of how secure the P2P network is, as well as what happens when you try to modify the transactional data. It's mostly based on a majority vote here. Apart from this, is also another preference that comes into the picture, but right now let's not talk about it and complicate things further. Now, moving on further, let's talk about how the distributed ledger system itself works in the P2P network. Now, let's say Andy is sending Bobby $5. Bobby is then giving Debbie $3 and Debbie thereby is giving Cindy $1. Now, this is a complete cycle that keeps happening, but we have only one central ledger which keeps tracks of it. What happens if this central ledger gets corrupted or some problems comes with respect to this data? Then the complete details with respect to the transaction is lost. Debbie can always tell that he's not taken $3 from Bobby, and same could be said by Bobby himself to Andy. Since the central record is not there anymore, there's no proof with respect to that same. And this is where exactly a distributed ledger comes. A distributed ledger ensures that everyone who's part of the cycle has a copy of the ledger, thereby ensuring that no fraud can happen or no changes with respect to that. Now, even if Andy loses his record of the transaction detail, he can take it from Bobby, Debbie or Cindy. And if either of them try to make a change with respect to that, always the alternative copy can ensure that this is the actual transaction that had happened. Okay, Dilip has a question here. Dilip is asking me, what if a majority of people come together to tell the transaction is false? Okay, Dilip, let me come to your question itself. Let's take the same example. Now, Andy has lost his copy, and what he's trying to do is he's taking a copy from Bobby, Debbie and Cindy. Now, Bobby has made a certain change with respect to the transaction details. He doesn't want to pay Andy back the $5, so he's made a change with respect to his ledger. Similarly, he requests Debbie to do the same. And what happens is that there's a conflict of interest that takes place, but since Bobby and Debbie have the majority, their decision is accepted. But let's look at a real-time scenario. At present, the blockchain network is distributed throughout the world. So if you want to modify a transaction and it has to get accepted, you need to be from the majority group. That is, you need to be more than 50% of the group that is part of the blockchain. This basically means that you need to influence more than 50% of the people who are spread throughout the world. Do you think that is possible? Definitely not. And this is what ensures that every transaction is highly secure as well. There are certain ways that this can be proved unsecure, but let's not go into that detail and complicate things even further for you today. Great, I'm happy that you've understood. Any other questions? Okay, that's good. So now moving forward, let's try to understand how a digital signature works with respect to it. Now, a digital signature is a very important part of the transaction detail because it ensures that the person who's sending the money is the real person, as well as the amount that is being transacted is the correct amount. So what happens is you mainly take the public key of the sender, the public key of the receiver, and as well as add the amount that has to get transmitted. Once you take this, it's fed to a hash algorithm and then it gets encrypted by a private key, which then is added as a digital signature to your document. Now, this is the same document that has the public key of the sender, public key of the receiver, as well as the amount. Once it gets transmitted across the network, you feed the data to a hash algorithm, which then again hashes the amount that has to be sent, the public key of the user, as well as the public key of receiver. You also decrypt the signature that is attached to this document using a public key that is being provided, and then you check if the hashes are same. If it is same, then it is understood that this is a valid transaction and this has not been modified as such while it is being propagated. So this in turn is another security feature that ensures that no transaction can be directly manipulated as well. Now, apart from this, another major key feature is the blockchain program. Now, the blockchain program is not something that can only be implemented in the banking domain. It's being right now implemented across multiple domains and has provided one of the new generation solutions, as well as overcome most of the challenges faced by a previous generation of applications. Apart from this, blockchain can be implemented using any language as per the user's requirement. But right now, Solidity is the most preferred language for writing blockchain programs. Talking about the blockchain transactions, in any blockchain, every transaction that gets verified and validated in the process of creation of a new block is logged along with the information of time, the participants, as well as the amount that gets transmitted across. Each node of the network, that is each user who's part of the blockchain, holds the complete blockchain in itself. So even once you join the blockchain, you get a complete copy of the blockchain from the start. Usually there's a 24-hour validation process that takes place, but after 24 hours, once you've set up your blockchain network, you can go on to perform various operations as part of it. Talking more about the transactions involved in a blockchain, each transaction is verified by a miner after he solves a complex mathematical puzzle. And once he solves this and verifies the transaction, he maintains and updates the ledger as well. Now, the mathematical principle which is involved as part of the validation process ensures that every node which is part of the blockchain are automatically and continuously in sync with respect to the current state of the ledger and every transaction in it. Basically, it ensures that everyone has the same set of transactions as well as same state of ledger as well. Apart from this, as I had mentioned, even if one person tries to corrupt or change the transaction part of it, the other nodes would not agree with it and thereby refuse to incorporate and neglect this transaction detail. Now moving forward, let's talk about three types of blockchain. There are mainly three types of blockchain. You have public blockchain, private and consortium blockchain. Now public blockchain is similar to your Bitcoin or Ethereum blockchain, which anyone in the world can be part of. You can both read as well as write data into this blockchain if you're a miner, and also you can read data if you're part of the peer-to-peer network as well. So anyone who's part of the network can verify and add a new block of transactions that is part to this blockchain. Private blockchain, however, is something that is quite restricted. Usually only one central person has the complete right to both verify the transaction as well as add a new block to the blockchain. However, consortium blockchain is something that is between public as well as private. Here what happens is that instead of one person, it becomes a group of people. Let's say there is a group of 10 banks. Among them, 5 may be chosen who can both verify as well as add a new block as part of the blockchain. Now, with respect to the view that is available, a public blockchain is something that anyone can access to. As we have seen, the Bitcoin as well as Ethereum blockchain is something that anyone can download and work with. But at the same time, private and consortium blockchains are created and managed with respect to their specific purposes. You may not always be able to access a private or a consortium blockchain because they may be set to a specific user's requirement. However, there are certain private as well as consortium blockchains which are accessible to the public, but again this is something that the user has to do, that is the creator of the blockchain has to set accordingly. Now if you do wish to create a blockchain which is accessible to the public but lets you only add or modify it, then definitely you can do that as well. And we'll talk about how this can be done as part of the session as well. So are you guys clear with respect to what we have discussed till here? Any doubts with what we have discussed? Okay, Mary is asking me, can we combine two different blockchains? Definitely, Mary, that also can be done, and it can be done to form a completely large blockchain as well. There are certain things that you would need to change, but definitely it is possible. Okay, Deepika has a very interesting question here. Deepika is asking me if I have to only use Bitcoins as part of my blockchain. Definitely not, Deepika. As I have mentioned, the blockchain which is used most popularly is the Bitcoin blockchain. Apart from that, you have Ethereum blockchain which mainly works around ethers. Let's say as part of the blockchain you want to convert your Ethereum to Bitcoins as well. That can be also done. You would be creating a sub blockchain called subchain where you will convert the Bitcoins or Ethereum to the other and then take it forward as part of the blockchain as well. So that is also possible with respect to that. Does that answer your question, Deepika? Okay, that's great. So let's just summarize what we have talked about blockchain. Blockchain basically uses various mathematical functions as well as algorithms to create a highly secure as well as a distributed ledger system which enables transactions to take place without a need for a third party or any need for transaction or commission requirement. You don't have to depend on a third party to take your transaction through, and this is one of the key reasons why the blockchain system is referred to as a no trust system. It's not that you don't trust someone, you don't have to put your trust on a third person to complete your transaction. It is something that gets completed without a problem. Now let's move forward and look at some of the blockchain use cases and understand where exactly is blockchain being used apart from the Bitcoin system. Now these are some of the most popular domains where blockchain at presently is being used. Now, we've talked about the banking domain where blockchain is currently replacing the existing as well as overtaking the current existing system as well as the payment and transactional system. The Bitcoin wallet system has grown so rapidly that it becomes quite easy for anyone to transfer their Bitcoins or cryptocurrency across to other users. And these days, as I had mentioned, you don't even need to bother entering their public key. All you need to do is scan a unique QR code that is present as part of their blockchain wallet, and the complete transaction happens right away. Apart from that, healthcare is a domain where blockchain is presently being used to store the details with respect to the patients. Now, this ensures that anyone who has access to this blockchain can access the details of the patients as such. So imagine what would happen if we had a nationwide blockchain with all the details with respect to the patients. Since it's highly secure, no one can directly access this detail and make any changes with respect to it, thereby ensuring the anonymity of the patient. But at the same time, let's say a doctor wants to see the details with respect to a patient. All he needs to do is give him his details, give him his public key through which he can access the complete details present on the blockchain and get the required data with respect to that same. Similarly, law enforcement agencies are using blockchain to ensure a highly accessible database comes up with respect to the criminals and the crimes that they have committed. So this is something that you can see coming out quite soon. Then coming to the election and voting domain. Now this is something that is a domain that is getting revolutionized with blockchain. We possibly might see the next or the next to next election made quite easy as well as secure and fail proof with the blockchain system. Apart from that, Internet of Things is another major domain that is currently using blockchain system to ensure the transfer of data between the devices without any corruptions as well as without any interference as such. Online music market is something that is rapidly growing to the blockchain system as well. Here what is happening is that the music domain is completely changing and putting up its music on the blockchain wherein anyone can have access to it but at the same time cannot make any modifications with respect to that. So let's say there's a specific customer who has paid for the song, then all I need to do is give him the details and he can take it from the blockchain as well. Apart from that, real estate domain is also being influenced by blockchain, and pretty soon I'm quite sure that you will be buying your properties directly off a real estate blockchain as well. Now, talking in detail with respect to the banking domain, blockchain has the possibility of cutting down $20 billion that is mainly taken up by middlemen. Now, this $20 billion is something that these middlemen organizations earn with respect to a year. Yes, although it does increase a chance of reduce of job with respect to these domains, but at the same time, imagine what could happen if banks themselves would implement blockchain. And that's exactly what they are being doing these days. And apart from that, the opportunity of hacking into the bank ledgers and making changes with respect to that same is becoming highly impossible as well for the people. Imagine what you would have done earlier was you would actually hack into a bank, make the changes in the ledger, take money from someone else's account, put it in your account. But now it's quite impossible because the only details that are present as part of the ledger is the transaction details, which as you know cannot be modified by a single person because the blockchain is designed as such. Also, it solves the problem of double spending. As we have discussed and seen how the double spending problem gets solved, this is something that can be quite useful for the digital banking domain system. Finally, talking about the risks involved with respect to that same. Since you have an idea of what is happening with respect to your money, you get a clearer idea as well. Rather than the conventional private ledger system that has been followed earlier, the next generation of distributed ledger system helps the people get certain clarity with respect to how exactly is their money being transacted and where exactly is their money at the moment. Although it again, as I have mentioned, maintains anonymity but gives you at least a clearer picture with respect to that same. Now apart from this, the payment and transfer domain is completely changing. Because of the security feature that is being provided by blockchain, this becomes a highly essential factor ensuring the ease of usage. Now Bitcoin is basically a system that runs on no transaction fees. Again, let's say if you do want a transaction to be completed on a very high priority, then it's up to you to add a specific transaction fees. Okay, Deepika, coming back to your question, I remember that you're asking me why would anyone add a transaction fees if you don't have to add it? Deepika, this is very simple. Let's say at a moment there are about 1 million transactions happening. Now a miner needs to validate them. Even though there's a huge number of miners, it's not easy for him to verify all the transactions that come in at the same time. So what he's going to do is that he's going to see if there's any incentive added or any transaction fees added as part of this verification process. So if there is a specific transaction added, then definitely he will pick up the transaction first rather than a transaction which does not have any transaction fees attached to it. So let's say there is a real-time transaction that you're doing. It's a very huge amount and you need it to be completed immediately. Then what you can do is you can attach a certain transaction fees to that. And this will ensure that your transaction is on a priority when compared to other transactions which do not have a transaction fees attached to it. This is another way how miners actually make up some amount of their own while they are investing their resource. But again, this does not mean that those transactions which does not have a transaction fees attached to it does not get verified. As I had mentioned, in the process of mining for a new block, most transactions do get added to the ledger and a new block gets created accordingly. So only if a new block is created, then do they get rewards. And to create a new block, they need to add transactions as well. So trust me, all the transactions do get through. Apart from that, you don't need any specific bank accounts that are required. You don't need to link your bank account to your Bitcoin wallet. You don't need to give the complete details. You don't need to attend to annoying calls that you get from banks and so forth. Apart from this, your anonymity is completely maintained. Now, as I have mentioned earlier, you are basically providing the public key as part of the ledger. Now, there is an upside and downside to it. The upside is that no one really knows who is the person who has the most balance or how much balance does each person have who's part of the blockchain. But at the downside, all of you do remember the ransomware attack. There what had happened was they had requested in terms of bitcoins and they had given their public ID. Now, even though the public ID was provided, it is not easy to identify who the person was at the other receiving end because their complete details are hashed and hidden as well. So there's always a positive and negative to certain technologies as well. Apart from these domains, election and voting domain is one domain that is expected to change completely with the involvement of blockchain. Using the blockchain, you can always authenticate the identity of everyone who's voting using their signature as well as secure their personal information. Now, this ensures that we are not quite sure who exactly has voted for which party, but at the same time their personal information is valid and is highly secure as such. Now, apart from this, it ensures that there's no vote frauds that happen as well as the loss of record does not take place. Now, as I have mentioned, any transaction that gets added to the blockchain becomes a permanent part of it. And you cannot modify it, thereby ensuring that voters fraud does not happen or any other kind of foul play does not take place. Now, this in turn is going to lead to increase in turnout because everyone is sure that no one is going to know about their votes. There's no tampering that's going to happen, as well as it becomes easier for people to become part of this blockchain and submit their votes. Now, this in turn is going to increase the voters turnout as well because there are certain organizations that are investing resources to build an application itself which makes it easy for people to vote from anywhere that they are. Wouldn't you like to vote for your party sitting at home or working from your office, making it sure that you have cast your vote, you have made your decision, you have supported for your party. At the same time, the details are not leaked and at your convenience as well. Now, one of the popular organizations working in the voting domain is Follow My Vote. They presently are trying to change the upcoming election ideas and trying to implement the online blockchain voting system by maybe the next or next elections as well. So hopefully let's keep our fingers crossed because I would definitely like to be part of a blockchain system that takes my vote and helps me support my party as well. Now, these are just some of the most popular domains. Apart from this, blockchain is being used in different domains and you have a lot of organizations who are coming in and investing in the blockchain technology as well. Now, to give you just a simple idea, some of you might have heard of the concept of Hyperledger. Now, this basically is a cross-industry collaborative effort from the Linux Foundation to support the blockchain distributed ledger system. Apart from that, organizations like JP Morgan and IBM are investing a lot of resource to build a public blockchain and increase the awareness, at the same time making a profit out of it at the show. So again, blockchain is not something that is restricted only to the banking domain. Because implementing a blockchain system is not very hard. It's quite easy. All you need to have is fundamental knowledge. Now moving on, let me help you understand how to work with a blockchain with our demo for today's session. Now the demo that we'll be performing today is going to be using Ethereum. Ethereum basically is an online open source publicly distributed blockchain system to which anyone can be a part of. It's similar to your Bitcoin system itself. Now, what we need to achieve as part of today's demo is that we need to implement a digital bank which actually implements the Ethereum blockchain. Now, this system has to allow us to do three things. First is make cryptocurrency with a fixed market supply and token that represents real world value. That basically means is that we need to create a cryptocurrency which has a fixed value outside. Apart from that, we need to autonomously create a private blockchain as well as mine for new ethers while validating the transactions. So if you're validating a transaction and creating a new block, you need to ensure that ethers are being provided to these miners as well. Okay, so let's not waste any time. Let's first begin by installing 𝐂𝐻 onto our system. Then let's register an account to 𝐂𝐻 blockchain. Then we'll be creating a private autonomous blockchain, and finally we'll try to perform few transactions internally. Now, as I had mentioned at the start of the session, these are basically dummy transactions that we'll be working on. But again, this should give you a complete idea of how a blockchain system works and how it effectively solves your problem. So first, let's begin by installing blockchain onto our system. Now, for this, the first thing that we need to do is that we need to clone the 𝐂𝐻 path that is present on the GitHub repository, and we need to create a local repository as part of it. Now, we'll be doing that on an Ubuntu virtual machine. So in case if you do have an Ubuntu virtual machine to your access immediately, you can go on and try it out simultaneously as I do. Or even if you have Ubuntu installed on your system, I would recommend that you try it out. So we're going to go step by step and I'll be explaining it to you completely. So even if you face any challenge at one step, I'll be able to assist you with respect to that same. Okay, so first let's begin by cloning the Git repository. Now the first thing that we're going to do is we're going to execute the command git clone, and then we're going to clone the 𝐂𝐻 repository present on Git. So for that, use the command git clone. Now this may take some time, so I request you to be a bit patient while this command gets executed, because the Git repository for 𝐂𝐻 is slightly big. Okay, so now that the repository has been cloned, let's go into the folder. So use cd go-ethereum, and let me show you the files that are present here. So these are all the files that are present in the 𝐂𝐻 folder. So now what we're going to do is that we're going to check out the tags or the versions which are present for 𝐂𝐻. For that, what you can do, you can check the commit issues. So this will give you an idea as to the different versions of 𝐂𝐻 that are present. So you can use the command git tag and you can see the different versions of 𝐂𝐻. Since 1.6.7 seems to be the latest version, we'll use that as part of our practical. Now what we're going to do is that we're going to create a branch of the version 1.6.7. For that, you can use the command git checkout tags / the version which you want to branch. So in this case, it's v1.6.7 followed by -b branch and the target destination. So what I'm going to do is that I'm going to set the target destination to be as Edureka Ethereum v1.6.7. Let me just increase the size. Now let me just show you the branch. For that, you can use the command git branch. Now before we move forward and begin the blockchain execution, you need to install the Go language as part of your system. Now to do that, what you can do is that you can go to the website. So if you search for Golang download, you can be directed to the official download page for Go language, and you can choose whichever package meets your requirement. If it's OS X, if it's Ubuntu, if it is Windows, you can choose correspondingly and install Golang. Now since I am using a 32-bit Ubuntu version, I have downloaded this package. Now it's time for me to extract and install it as part of my system. To do that, let me just open a new terminal. Let's maximize this as well. And here, let me go to my home directory where the file is present. So by default, it would be stored in your downloads. So I recommend that you open a new terminal and ensure that the package is present into your home directory. So this is the file that I have downloaded. Now it's time to extract this. So for extracting and installing this file, you'll use the command sudo tar -xbf, following which you'll specify the file name. Always ensure that you're extracting the correct file. So the name of file is go 1.8.3 linux-386. Now if you're using a 64-bit, the file extension may change. Now once you specify that, just hit on enter and the extraction and installation will start. But before that, always ensure you're using the sudo command to execute this. because this requires administrative privileges. Now as you can see, the Go language is getting extracted and installed onto my system, and it has successfully extracted it. Now what I need to do is that I need to move it to a specific location, that is my /user/local. This is mainly to ensure that I have ease of access to this language whenever needed. So for this you can use the following command, that is sudo move go, that is the folder to which it has been extracted to user/local. Now make sure that you execute it and the file would have moved. Now just to check if the file is successfully moved, you can go to the directory, that is cd/user/local, and check if the file is present here. Sorry about that. So here you can see the Go folder is present. Once you've done this, just close this terminal. Now before you finally complete and execute this, the last step that you need to do is open a new terminal, and here you can try the command sudo.getit.bashrc. Now this is mainly to add the environment variables to my list of variables. So here there are 3 lines that you need to add. First is export go root is equal to the location where Go variable has been moved to. So once you set the Go root, then what you need to do is that you need to specify the working folder. For that, what you're going to specify is the Go path variable. So for that you can use the following syntax, that is go path is equal to my home directory /project/project1. Now this can be set to any location as per your requirement. I'm just setting it as to the following. Finally, what you need to do is you need to add this to your path list. So the command is going to be the following: path is equal to the syntax that has been specified here, that is go path /bin : go root /bin : path variable. So once you do this, you can save your bash.rc and close it. Finally, use the command source.bashrc to ensure that the bash file gets restarted. Now to check if the Golang has been installed successfully, just execute the command go version, and you can see it has successfully been installed. Now if there is certain change with respect to this, if you're not getting this command, then you have missed out on any of the steps. So please let me know in case if you're facing any troubles. I'm forwarding all of you the commands here as well. Great, now that all of you have successfully installed Golang as well, so let's close this and let's go back to our Go Ethereum terminal, and here what you need to do finally is that you need to execute the make all command. Okay, sometimes this tends to happen, so what you can do is just close this, open a new terminal. Let's go back to our Go Ethereum folder, and here just check the Go version. Yes, this is working. So sometimes what happens is an existing terminal does not accept the updated value. So in that case, just open a new terminal and execute the following command. So now the final command that we need to execute is make all. So here just execute make all. So as you can see, it's getting executed. So what it does is that it basically tells Git to build the target file as per the input with respect to it works. So again, this may take some time, so I request you to be a bit patient. Great, so with this we've completed the first phase of our demo. What we have successfully done is that we have successfully cloned the get code from the Git repository. Now the next step is to create a Genesis block. Now what exactly is a Genesis block? Genesis block is always referred to as the first block or the 0th block for a blockchain. It basically contains the details with respect to the blockchain. So what we'll do is we'll first begin by creating a Genesis folder, and then we'll add a Genesis JSON file into it. So what we'll be doing is in our Go Ethereum directory, we'll be creating a new folder called Genesis. Now let's go into the Genesis folder. And here you need to create a new JSON file which has all the details of the Genesis block. So for that, use the command get it Genesis, and I'll just name it genesis3.json, and let's add the code. Now what has to be present in the Genesis block? Let's discuss about that. Now in a Genesis block, you define the different rules for our blockchain. So for that, what you have to do is you need to understand this code. So let me just give you a brief summary as to what is present as part of this code. Now let's start by the simple things. Timestamp basically is a timestamp, and exabyte basically is the extra 32-bit memory that you can use to pass any message with respect to that same. Then comes difficulty. Difficulty basically is how difficult is it going to be to mine a specific block as part of the blockchain. So you can set this difficulty and modify it as per your requirement. Then coming to Coinbase. Coinbase is basically the address to which the coins have to be sent to after the block has successfully been mined. Then comes your parent hash. Parent hash basically is the hash code of a parent. In a blockchain, every block has the hash code of the previous block, and this is how you identify which is a valid block or not. So in our case, we are setting the value of parent hash as well as Coinbase to 0. And now we'll talk about both nonce as well as the mixed hash value. A mixed hash value is a value that is kept fixed throughout your blockchain, but your nonce is the key value that needs to be computed by every miner. Okay, the combination of your nonce as well as your mixed hash is something known as a proof of work. You need to get a specific hash value with the combination of nonce and mixed hash, which is less than the set value for a block. How is this value defined? There's a certain mathematical logic associated to it. So let's not go there now. Basically what you need to do is that you need to identify the value of nonce. Once you've identified this value and added it to the mixed hash, it should be equivalent or lesser than the mathematical value set for that block. Now, this is where the resource gets invested. The value of nonce is something that you get by trial and error method. Now, it was believed that in the year 2014, the value for nonce had to be tried between 1.4 till 15 quadrillion values. So you can understand how much effort it takes. This is exactly why I said one block cannot be completely solved by a single user and requires a lot of computational power by a user. And this is why in today's world, most miners come together to form a pool where the work gets distributed among them. They try out different values accordingly, and once the block gets solved, the incentive gets distributed among the people involved. So I hope this has also given you an idea as to what is the role of a miner as such. Okay, so two things that we're left out with is gas limit. Gas limit basically is the limit of gas or resource that you can spend while mining a block. What happens if too many people invest too much of resource? Then it becomes easier for them to mine the block. So there's a certain limit set for that. So that is what exactly is your gas limit. And finally, alloc is the last command that you have here. This is mainly used to define a list of pre-filled wallets. Now, since we are not using pre-filled wallet system, we have left it empty here. Great. Now let's add this code as part of our Genesis block. Now I have also shared it with you, so make sure you're doing it simultaneously. So let me just add it here and save it. So once you've completed this, we are done with step 3. Now it's time to initialize our blockchain. So for that, let's go back to our presentation. Now for starting your blockchain, you need to execute the following command, that is home/edureka/go-ethereum. Now Edureka will be replaced by the user that you have specified. Then inside the go-ethereum, you need to go inside the build, bin and get, and there you need to specify the data directory which is of the Genesis file. So that is Ethereum net3 init genesis3.json. So let me just execute this. Now let's go back to our home directory, and here let's execute the command that I have just shared with all of you. Now this command will help you start the Go Ethereum blockchain. Great, now that we have initialized the blockchain, it's time that we get the get console access. Now the get console is important because all the commands that you need to execute as part of the blockchain are commands that get executed on the get console. So for that we'll use the following command, where the only variation is with respect to the network ID, where you have previously initialized the Genesis file. Here you need to use the network ID 3 console. Okay, I'm sharing the command with all of you. Please make sure that you're executing this as well. Once you've done with this, you get direct access to the get console, where we'll be executing certain commands. So as you can see, the get console is getting initialized, and here you have the get console initialized. So now let's discuss about the various commands that we're going to use as part of today's session. So we need to create new account, as we had discussed as part of the problem statement. We need to check the balance. We also need to mine and check the wallet balance of each of the miners. So for that, let's go back to the slide and discuss each one of them one by one. Now the first command that we need to execute is personal.newAccounts. Now this creates a new account as part of your blockchain which has a specific wallet attached to it. So every time that the blockchain mining happens, the wallet gets updated with respect to the Ether value. Apart from that, the next command is eth.accounts, which will help you check the various accounts which are part of the blockchain. Then you have eth.block number. Now this helps you identify the total number of blocks which are part of your present blockchain. Then you have miner.start. This starts the mining operation, and to stop the mining operation you can use the command miner.stop. Finally, you have eth.block_number, which tells you at which block you are after performing the mining operation. And finally, the command that is eth.getBalance will help you identify what is the balance in a specific account. Now this is basically the account details that we had seen earlier. It is a hash value and you get it as soon as you create an account. So now let's go back to our console and begin by executing each of these commands one by one. Now, as we have discussed, the first command that we'll be executing is for creating a new account. So that is personal.newAccount. Now, one thing to remember is that A is capital here. And once you hit on enter, it asks you for a passphrase, which is quite similar to your password. So once you set a specific passphrase, it will ask you to confirm it again. Once you've entered the passphrase, it begins the creation of a new account and you get the account number added here. Now let's see which are the accounts as part of your present blockchain. So for that, use eth.accounts and it will give you a complete list of all the accounts part of your blockchain. So I have been using this blockchain for a while. So there are different accounts which are part of my blockchain. So since you are creating an account for the first time, you'll just have one account. I'd recommend that you create 2 accounts at least before you go ahead with the next step. So you just need to execute the previous command, that is personal.newAccounts, to create the second account as well. Please let me know once you've done that. Okay, great. So now that you've all created at least 2 accounts, let's check on which block I am at present. So for that, use the command eth.block_number. And here remember n is capital. So once you do this, you get the value of the block number. Now I am at 3326 because I have already used this operation before, but you may get the value as 0 because you might be on the 0th block. Okay, so let's start our mining operation. For that, which command are we going to use? That's correct, Aditya. We're going to use miner.start. Now once you do this, it may take certain time for the resource to get allocated and the mining to start, so I request you to be a bit patient. And what we're going to do is that we're going to execute this mining operation for the next 10 minutes and let's see how it goes. So as you can see here, the mining operation has started and we are mining newer blocks as well. So let me run this operation for the next 10 minutes and let's see how it goes. Okay, so now we have run our mining operation for 10 minutes. Let me just stop this. So for that, we are going to use the command miner.stop. And once you execute it, if you get true, that means the mining operation has stopped. Now let's see which block we are presently in. So for that, which command do we have to use? That's correct, Deepika. We're going to use the command eth.block_number. Now if you can see, we are at block 3367. Who remembers the first block before we started the mining operation? Yes, it was 3326. So we've mined close to 41 blocks in just 10 minutes. Now this is because we have set a specific value of difficulty. If you want, you can increase it. You can change the value of that, thereby increasing the time for mining a block. So I request that you try that out by changing the values in the Genesis blocks. Now it's time that we go to the last step, that is to check the balance of an account. Now let me just see all the accounts that are part of this blockchain. So for that, we're going to use the command eth.accounts. Now to check the balance, you need to use the command eth.getBalance. Again, here B is capital. And here you need to specify the account number. So let me just pick the first account number here. I'll copy it and pass it as a parameter for my getBalance function. Now when you hit enter, you can see the corresponding value of Ether that is present in this account. Now since this was my first account, it has a certain specific value. Now the more time that you run your mining operation, more will the Ether get created and added to these accounts. Now if you see newer accounts, they may not have the same Ether that are present there. It gets distributed according to how much resource has been put in by each miner. In this case, the first account has been there for longer time. But if you see the latest account, if I execute this, then you see the balance to be 0 because it has not contributed that much as part of this block. So I would request that you try mining it for a while, maybe try mining about 500 or 600 blocks, and then you can see the difference with respect to the latest account that you have added. Is that okay? Are you guys clear till here? Any problem with respect to what we have seen? Okay, Deepika is asking me why is it written 5 blocks to confirm. Okay, Deepika, there's usually a wait or a delay that is present as part of every block. For usually it is 3 with respect to a Bitcoin blockchain. Here it is being 5 to confirm. So it's always suggested that you wait at least 5 blocks to confirm any transaction or to confirm if any block is part of a blockchain. There is a specific fixed period. It changes from blockchain to blockchain. Now, why that happens, we'll be discussing as part of the next session, where we will see the problems that are faced when you are trying to insert a false node or a false transaction as part of the blockchain. Okay, great. Now, coming back to our presentation, with this we come to a conclusion of today's session. Just to summarize what we have learned, we started off by understanding what would a world look like without banks. We even saw the Bitcoin history and how blockchain helps with the Bitcoin solution. After that, we talked about the various blockchain concepts and the blockchain use case, and finally we saw the demo as part of today's session. I hope to see you guys all for the next session. Hope you have a great weekend. Happy learning. Thank you.